Okay, what we're doing today with Percy here is multiplying and dividing rational expressions. Your vocabulary is rational expression and complex fraction. And it's not going to be hard, but you must be able to factor. All that stuff we did yesterday, you need to be able to do it today. So, tricks to remember. When we are dividing fractions, you don't actually divide. You flip the second so you get its reciprocal, and then you're going to multiply straight across. 3 over 4 divided by a over b is equal to 3 over 4 times b over a. And then you just multiply straight across. 3b, 4a. When you're dividing, anything that appears on both the top and the bottom can be crossed out. So here, first is going to do this one. There's an a on top, an a on the bottom. So you're left with 3bx equals z. So here's today's lesson. Simplify this expression. Right now, there is nothing on the top that's on the bottom. But if we factor this right here, we learned those skills that MA method from yesterday. It's a highlighter. Right here, we took the time to do an MA method for that. We could rewrite that like this. 5x times x plus 3 times x plus 1. And now we can cross off what's on the top and the bottom. There's an x plus 3 and an x plus 3. And that will give us our final answer. Crossed off the x plus 3's of this. We can simplify that a little bit more. No, we can't. We could say 5x squared plus 5x. We don't have to. Next problem. Sometimes you're going to be asked, under what conditions is this expression undefined? And that just means, when does the bottom equal 0? So if you have all of this, highlighter again, on the bottom of your fraction, take each piece, like I did here, and set them equal to 0. Solve each one for x, and that's your answer. That's when the expression is undefined. Here's another one. For what value is this undefined? Start with the bottom. I have this equals 0. I factored the middle guy. That gave me x plus 2 times x plus 4. I set all three of these equal to 0. 1, 2, 3, and solve for x. The expression is undefined when x equals 0, x equals -2, and x equals -4. The answer was C. Here's a different one. Simplify this problem. We're going to have to factor. Up the top, I see an expression right here. I can pull a greatest common factor out of there. I can pull a W out. If I pull a W out, this is what I'm left with. I still don't have anything on the top and on the bottom, but I do have things that are kind of close. Look at that, 4W minus 3Y and 3Y minus 4W. When you have things that are kind of close, you can stick a -1 in there. See that -1? They then flipped that top one so it matched up with the bottom. Now you have 3Y minus 4W on the top, cross it off, and on the bottom, cross it off. Rewrite the problem with the things crossed off. There's your answer. Next problem. This one's easy. You'll like this one. Simplify each expression, multiply straight across. Remember to add your exponents, and then we can do just easy this. There is a 5 on the bottom and a 15 on top. Both of those can be divided by 5. That gives us 1. That one gives us 3. There's a 6 and an 8. Both of those can be divided by 2. That gives us 4 and 3. There's a d squared on the top and a d on the bottom. I can cross off the square. Can I cross anything else off? No, I can't. 3 times c times 3 times c times d is 9c squared d. And then in the bottom, 1 times 4 times a is just 4a. That one's easy. You can do it when it's dividing too. Remember, all you have to do is flip the fraction, the second fraction, and then just multiply straight across. So that's going to give me this expression. I'm going to cross off repeats. I've got an a squared and an a squared. I've got a 1x up here. Marker's not working, hang on. 1x up here, and I can cross off the square here. Got a y, I can cross off the cube and make it a square. Now with the numbers, 18 can be divided by 6 3 times. 12 can be divided by 6 twice. 7 can be divided by 7 once. 35 can be divided by 7 5 times. Oops, and I missed a b. Here's one b. Cross off that square. Leave me one b on the bottom. Multiply straight across. There's my answer. You're just crossing off things that appear on the top and the bottom. Here's another problem. The steps are going to be the same. It starts off as division. So what you need to do is flip the second fraction. Turn it into a multiplication problem. Next step, factor. Y squared minus 3y minus 18 turns into this. X squared minus 12x plus 32 turns into this. Over here I can pull a 12 out of both sides. And over here, do you remember that green sheet you have about factoring? Oops, undo that. That green sheet shows you how to do the difference of perfect squares. X plus 4 times x minus 4. Now we just cross off whatever is on the top and the bottom. There's an x minus 4. Oh my goodness, this is so slow. X minus 4, x minus 4. X plus 3, x plus 3. Rewrite the problem. You can simplify it if you want. You can FOIL the top and distribute on the bottom, or you can leave it just as it is. Last problem. This is your other vocabulary. It's called the complex fraction. It's two fractions. It's a fraction on top of a fraction. Well, the first thing you want to do is get rid of the complex fraction. Rewrite it. Make it a normal division problem. Top divided by the bottom. Now you can flip that and turn it into a multiplication problem. Now what do you see on the top and the bottom? You see a 4 and a 4. Those cross out. Your final answer is a plus b over a squared plus b squared. That's it. That's how to multiply and divide rational expressions. If it's on the top and the bottom, you can cross it off. What do you need to remember? Factoring. You can't do this without factoring. I'm sorry. Also remember that dividing is the same as multiplying by the reciprocal. That should be enough to get you through this.